All right, we are live. Let me just check everything real quick so that we. Okay, everything is working. All right, everyone, welcome back to the channel. And it's been a while, so I'm back to like. Also, uh, okay. If you're watching the live, like replay of this live, you can skip to like 2 minutes, and I will like start talking. Then I need to get in the mood of life. It's been a it's been some time, and oh yeah, there's going to be a lot of accidents today. All right, so ah, 2 minutes. We will start at 2 minutes. Also, let me just give you updates till the 2 minutes comes in. Firstly, the lives that I was doing, and if you were following the previous live of the horror gaming and stuff, I have stopped them because they were kind of like taking too much time. Like I was not really developing anything. I was more like explaining most of the stuff. So I have stopped them, and I'm making these kind of lives now, which is much more depth. Like now I'm properly teaching you rather than just like most of the time I was just debugging there. All right, 2 minutes is up. Let's go. All right, so welcome everyone, and in this video, we're going to go over the actual workings of computer and programming and coding. Okay, like how everything really works in there, and what do we need to understand before moving into game development and any kind of other programming activities. Okay, so let's go. Let's talk about it. Okay, so firstly, what is computer's language? Like, what do they really understand? I mean, if you have a mic, right, and computer cannot understand the mic language, but you can record in it, computer will never really know what you're trying to say. Nowadays, there are no, not amplifiers, but computers can understand your voice these days. You can send voice messages to Google, and it can decode it and give you answers accordingly, right? Computers nowadays can convert text to no, voice to text, and even text to voice. They can do this stuff, but in depth, right? In reality, in machine, what is the language of computer? It's on off. Computer works when there are multiple of the components that are basically off, and multiple of the components that are on. And these all on-off components basically means transistors. Transistors in your CPU, your graphic card, and anything else that might have them. Some of them are on, and some of them are off, and your CPU knows what to do with them, basically. And they work on instructions. Now let's go a little bit more deeper than this. What is on off, right? And let's go over a little bit much more explanatory explanation. Okay, so firstly, let's see off as 0 and on as 1. We all do that. If you are in computer field, you know what this 0 1 means. This is the binary code that computer works in. Okay, you can call it a binary code that way. Everything that you do in computers get decoded into zeros and ones. Everything that you do. Your CPU can only understand zeros and ones. It cannot understand A, B, C. Okay, and it is there forever. Even if nowadays your computer can understand your voice, it can understand what you type in it, it can, like, you have ChatGPT which just, like, you write a sentence and it knows what to do. It knows all of those things, but it has decoders that decode all of those content into zeros and ones, and then again the AI and the computer do the working in again zeros and ones, and then we have encoders that basically package everything and give in a human language back. Okay, so that's how the actual communication between human and computers work. We have, let me just erase these. Okay, so we have a human and we have a computer. Let me move it to that side if I can. Okay. Okay, so we have a computer over here and we have a human. Okay, so human will send a information like 2 plus 2. Computer cannot understand what 2 plus 2 means. So we will have a, this time we will call it an encoder or maybe just a transformer. Okay, it transforms 2 plus 2 into binary kind of code. It won't look like this, but this is just representation. Okay, then computer gets it. It process on it, like it will check, okay, 2 plus 2, okay, it is 4, but it cannot tell you that it's 4 because it also in itself doesn't know that it's 4. It just knows the binary number of that particular output. Okay, so it will send back the output for the 4, so it can be like whatever. Okay, right now again I'm not putting the actual number for the 4, it's just representation that it says it is in binary. And then we have again decoder or encoders that transforms the binary code back to the human understandable language, and it gives back 4 to us. Okay, that's how the communication works in internal, I'm talking about. Overall you don't really see this because on monitor you have everything that you need, in keyboards you have basically everything that you need, so you can give input, get output pretty instantly, and you don't really think about this particular conversation that is actually happening behind the scenes. But this is happening every single time, every single tick. Okay, even if your computer's tick, all of those gigahertz, every single hertz, these communications are happening. So now, what do we get from this? We get that computer doesn't really understand us. They don't understand if we want to add 2 plus 2 or we want to multiply 2 plus 2. Okay, that means if let's test it out. Okay, whatever your choice of AI is, or even if you Google search it, search this thing, add 2 into 2. Now this is very confusing even for a human, but a computer doesn't ask questions. It just does stuff. Whatever you tell it to, whatever you give instruction it to, it will just try to do them. Okay, maybe the answer will be completely ridiculous or not what you want, but it will still do it. This right here is a human input error command. Okay, there is an human input error here. We cannot add here and have it multiply again and not have another kind of equation behind that maybe we want to act together. So right now we are just kind of like thinking, okay, we are trying to add 2 with 2, or are we trying to multiply it and add it to something else? It's very confusing. But what does computer do? It can do depends what it really wants to do. So let's go. Firstly, what computers can do is they can think that add is just secondary. Okay, we're not going to think about that, and it will just multiply 2 into 2, which will give us 4. But wait a minute, the answers are going to be the same. So, correct. So now what we can do, okay, I just replaced one of the twos with 4, so we get different answers while multiplying and adding them. Okay. So one of the results that can be is that it will multiply them rather than adding them together. Okay, and it will say 8 here. It will give result of 8. Other way it can be that it will add both of them rather than multiplying it, and maybe think of x like something else, because in computer language multiply is the star, not the x. So it will add them, and it will, like, say it can be like 2 plus x plus 4, and if we add them it will be 6 plus x, I guess. It can give this output, or it will just completely ask you, what do you really want to do? Do you want to multiply them or do you want to add them? So these are the things that can happen in computer. You give them instructions can be misleading or incorrect, and computer will try its best to give you the output. If we do have fail-safe on the computers or on the program, like Google have all kinds of fail-safe, if you do enter this kind of search in Google, it will immediately ask you that, did you input it wrong? Do you mean something else? And do you mean add 2 and 4, or do you mean add 2x plus 4? Or it will ask you a lot of questions. It can ask you in multiple ways as well. Okay, it depends. Okay, it depends what kind of misleading statement you have created for the Google. It depends. All right, so that's how computer works. They don't know what do you mean. Maybe you changed your mind, you wanted to add, but then you remembered that you want to multiply, but you forget to remove the add. So it does all of those things. So that's what happens. Computer does not understand your intent. It does not understand what you assumed. It just understands what it knows, what kind of instruction we have given us, okay, given to it. All right, now we know that computer works in its own language. It only understands zeros and ones, and those zeros and ones get transformed from the instruction that we give it, and it will work on those information. And if we don't have failsafe, it will completely stop working. It will not give output to you. Okay, so those are the things. And let me just erase everything. Entire. Okay. Tish, tish, tish. So let's do a simple exercise using a table. Okay, I have a table over here which gives us kind of a rough idea of every single uh, binary digit get transformed into a decimal, which decimal means the whole numbers. Okay, so if you want to add 2 plus 2, in computer in itself, it will say that we want to add 10 and 10. Not exactly 10 and 10, it will be 1 0 and 1 0. You have to add 1 0 and 1 0 together. And in computer, it will output this as the result. It's not really adding them together. It's not like saying 20. It is kind of adding its own number, I guess. So computer does the all of the processing, and then it gets to a position. It claims a output, and then in the output it tracks like, okay, the binary code for the output is this, then it sends back, then the decoder transport it back to the human understandable, which is the decimal or the whole numbers, and it will give us back 4. You can also do it in the multiply. If we try to multiply 2 into 4, which we should give us 8, then we are basically multiplying 10, again 1 0 with 1 0 0. It will give us what is 8? 1000. Okay, so that's how kind of everything is basically working. Okay, so now what we want to do with this is, let's think of a simple code that adds and subtract and few things, and we're going to look into like what is the computer thinking and what we think that the computer thinks. I'm completely messing this. Okay, so I have a simple code. Okay, and I'm not really going to write a syntax. I'm just going to write like what we are doing in these things. We have two numbers. We will first state that we have 2 and 3 and 4. Let's go with 3 numbers. Then we will say that we want to add 2 plus 3. Okay, and it will be much better if I give you it in variables. So we have a is equals to 2, then we have b equals to 3, and we have c equals to 4. Okay, then we can go like a plus b, then b plus c, and then a plus c. Right, and what we are basically doing is we are giving all of these values. So a plus b will be the c, b plus c will be a, and a plus c will be b. Okay, and then we're going to multiply a, multiply b, multiply c, and we then going to print whatever this is, can make it d. Okay, so we will print d. It's a pretty simple code, but let's see what computer and humans are thinking like going on. If you give it to a human, I mean me, I will think like these might be the things that are happening. So especially we will go, okay, a is 2, b is 3, c is 4, but over here we are changing the value of c, which means a plus b, which is 2 plus 3, 5. So now a is 2, b is 3, and c is 5. Okay, now b, which is 3, and c, which is 5, now is given to a, so that will be a equals to 3 5 8, b equals to 3, and c equals to 5. Then we have a plus c, which we put in b, so it will be 8 plus 5, which will be 13. Yeah, 13. So a equals to 8, b equals to 13, and c equals to 5. Now we are basically multiplying all of them together to get a much better answer, much bigger answer. All right, so 8, 5 is 40. So we're going to go with that. So we are basically multiplying 40 with 13, which will result in 2, 1, 2, 2, yeah, 5, right? Yeah, right? Uh, uh, yeah. Okay, it's correctly. Okay, so that's what we are basically doing here. Okay, this is a human interpretation of what code should do and what code should print. This is this should be the output. Now, what AI think? AI doesn't know what A is. If AI doesn't know what B is, C is. AI doesn't know what 2, 3, 5 is. But not also not AI. I mean computer in sense. So let's go over in what computer might do. Okay. So let's think of ABC as memory slots. Okay. So we have these memory blocks that exist in the world. Okay. And these memory blocks will contain our binary code for ABC. So for Q, it's 10. For P, it's 11. Also, it's not 11 and it's not 10. It's 10 and 11. Make sure to say it like that. And we have 5, which means it's going to be 101. Yeah, 101. Okay. Then what we are doing, we are adding it to the 10. We are adding it to the 8. Okay. So to the next one. A 8 becomes 8, which is 1000. Okay, B stays 11, and also B stays 11, and C stays 101. Now A stays 1000, and B goes to, wait a minute. Also, yeah, this C is 5. This should be 4, but we are starting with this one. Okay, this is how we are going forward. Sorry about that. Hmm. All right, let's go. Okay, so B13. B13, we need to think about this. 8 is this, 9 is this, 10 is this, 11 is this, 12 is this, and 13 is this. Okay, if we convert them to binary, it will look something like this. Do we have 13 in the chart? Yes. As you can see, it is 1101. So now we have A, which is 1000. We have B, which is 1101. And then we have C, which is 101. Now, by just looking at these equations, we cannot really understand the computer language, but computer understands it completely. Like, it knows everything and it knows how to go with all of these things. Okay. Now, what we're going to do is we're going to multiply them. And by multiplying, we get 520. Now, there is a way to convert a binary code, which is in 10, to uh, a decimal code to a binary code, which is in 2. There are multiple methods from which you can do this. And one of my favorite, if you do want to know, let me just search what it is called. Binary. To binary convert. Okay, so there is no name for this. Oh, well, anyways, what you basically have to do is do the LCM and HCF kind of stuff. Okay, and that is basically dividing this product, this thing, by two. Okay, let me show you to you. So if we have 520 over here and we divide it by 2, okay, then it will give us 2, then 6 and 0, and it will give us 0 in the remainder. We're going to do it again and it will give us 1 3 0 0 0 again, and then we're going to divide it by 2 again. It will give us 12 6 5 again 0, not in this one. Now we're going to divide it by 2 again. It will give us 3 2.5, which will be 1. Not 2.5. Okay. It will be 32 and it will give us a remainder of 1. Okay. Then we're going to divide it by 2 again. It will be 16 0 2 again. It will be 0 8 2 again. It will be, oh my god, it's a pretty good number. And it will be 0 and 0 again, and it will be 0 again and then 1. Okay, so this is the binary code that we want. The actual binary code for 520 will be this: 1 0 0 0 0 0 1 0 0 0. So what computer actually output is not exactly 520. Like, it doesn't say, okay, the number that I want to give you is 520, or and it also not give you like in a way that gives binary code for 5, then it gives binary code for 2, and then for 0. It does not do that either. Okay, because if it does do that, it will look something like 1 0 1, and then for 2 it will be 1 0, and for 0 it's just 0. So yeah, it will give us this code, which is exactly don't exactly not what we want. Now if you want to, I can actually give you a binary to decimal converter. There are online converters that you can check on. Okay, so if I enter this binary number, which is 1, okay, 1 0 0 0, then 0 0, then 1, and then 0 0 0, will give us 520, just what we wanted. And now let's check what this code does. Okay, what this code give us: 1 0 1 1 0 0. It's for 44, which is completely different number, completely like the actual number should be multiples of it, right? So yeah, it is a pretty amazing thing that we get. Firstly, they do kind of like think of them as memory blocks, right? All of these variables, they think of them like memories in your system, and then all of these blocks are the contents of it. Okay, all right. Let me just do this real quick. I don't know why, but I'm way past. Okay. Now that we know all of these things, let's move on to a much expendable topic. Okay, and that is, what is like the human, like why do we get to see what we see, like all of the motherboards, not the motherboards, but right now you're seeing this video, and maybe when you're operating on a game, you are kind of in depth, but you're still using a engine for this. You're not making a game in zeros and ones, right? So how is this user interface so much better? Like, why is this there? And let me tell you that this is the only reason why we think that computers are much and much smarter these days. It's just the improvement of the inputs in the computers. Okay, so let me give you a quick idea. Let me just raise these things. Okay, right. So let's go. Ah, okay. Let's go. So main topic, not the main topic. Okay. Ah, let me calm myself down. Humans and inputs. Okay. So in computers, if you don't really know this till this point, because I was trying to make this thing apparent, which is we give input, computer process on it, and it gives us output. Okay, we give it input, it processes it, and it gives out output. Now let's go over like in the early stages of the computers. Okay, when we used punching machine to punch out Morse codes and stuff. Not exactly Morse code. I think it was a completely different thing, kind of the OMR sheet, which we then give it to the computer, and then computer process on it, and then it will give us output. Okay, it, the process was still the same. This particular process, this particular chain was still the same to this day from the point the computers were made. Now, how they are actually smarter though? Why do we feel them to be much smarter than what they were before? And two things are actually factors of this. Firstly, the speed. They can do more stuff than they were able to do before. Okay. Nowadays, you can do calculation like 2 plus 2 very easily, but you can also do calculation that are much bigger, much faster as well, right? Mm, But back in the day, even 2 plus 2 used to take minutes, not hours, to for the computer to calculate. Okay, so the speed is a much better factor, like much major factor in us experiencing computers as much smarter. And the other thing is input itself. Nowadays, if you input something like, again, what I said before, 2 into 2, computer doesn't really understand this. Again, as I said, it's all about the decoders. Computer doesn't understand 2 into 2, and back in the day we used to not have any kind of decoders. They only work with 0 and 1, stuff like that. So the engineers have to make sheets where they will have punch holes. Okay, so that's how the punching hole machine, let me just present it to you. Okay, so how punching hole machine work, and what it kind of represent is that, let's say that we have 2 into 2, we want to do this, right? So what will happen is that we will leave blanks. So as we remember, the 2 is 1 and 0. So what we will do is we will leave this section off. Okay, and we will fill this section. Okay, and we're going to keep everything else blank. Okay, so with this we get that we are trying to say that over here we inputted 2. Then in the next one, there will be a special modifier, a special code of this on off binary code for just multiply. Okay, so there will be a special code for that, and we will punch that in, and then we will have another code for 2 here, and then we insert this file into the computer, which computer then operates on and will get the output from this sheet. It is very specific, and if you mess up one thing, if you opened this hole when it should be closed, or if you closed this hole with the other one closed, like, it can cause multiple problems. It will give you a false answer because the input was ne negative, basically, incorrect. Okay, so but nowadays, if you just say it like 2 into 2, the decoder will decode everything that it can. Then it will also like check for any kind of problems. Maybe you didn't misspell anything. Maybe there is some kind of syntax error. Maybe some kind of like user error, known user error. And it will go through all of those things. And then it will send to the PC to do the mathematics of it and then give back the output. Okay. So that's the increase in input. Nowadays, we just click a button and we turn on the website. But if we have to do this with previous systems, even if they, let's say, would be faster, but the input system was still the same, then it would have been a book. And I mean it, like a book amount of input just to open up a website. Okay, a whole book you will need to just go by one single day of working on a computer. Or maybe more than that. Maybe you need a library to actually keep on working with the computer. Because back in the day, they used to have a library of every single code that they may want to process on. So that's the benefit of it. We have the speed and we have much better input. Output, yeah, output have also increased, but mostly output is just basically computer giving you the output of whatever it thinks. Back in the day, it used to give output in binary code, so we need to deduct it, like decode everything. We need to go through every single number, and there can be another human errors where they may decode it incorrectly, and we get these different result than what we wanted. So yeah, it was tough back in the day. So now we know that input and speed increased the amount of with which computer works, basically making them much smarter in our eyes, whereas they are still doing these three particular main processes. We are basically inputting it to them, they are processing the input and giving us the output. That's it. All right. Now, the first part of the live is done. I think I have explained, okay, I have explained what computer works, how computer works, okay? But now let me give you another thing. Now let me tell you the coding process of it, the programs of it, which is all included in this particular process, okay? When computer processes, it goes through the quote unquote programs and codes to do the whatever the input are telling us to do. Okay, so let's get into it. What coding really is. Let me erase it all over again. All right. So, what coding really is. So, firstly, let's think about the simple instructions. Okay, Coding, don't think of it as like a syntax method or with which we operate on computers and all of these things. Don't think of it like like all of those messy codings and stuff. Don't think of it like that. Okay, keep that thing out of your mind. Don't even think like they exist. Okay, for now, just throw them out. We're going to think of them as like a manager who is managing a line of kids, okay, going to let's say a roller coaster or maybe a Ferris wheel. Okay, so there's something fun to do here, and there is a manager controlling like which kid will go, how many kids will go at once, and yeah, stuff like that. Okay, so this is how it's happened. These kids are inputs. This manager is the, you can call it the one who instruct everything, okay? Or we can call it the instruction, okay? And the fun part, the Ferris wheel or the roller coaster and all of those things, that's the process. Okay, we are forgetting about the output right now, but we can think of it output as the happiness, okay? Right now, just forget about the output. So we give the inputs to the whole process of the instructor sending the inputs to the Ferris wheel or the roller coasters. Okay, it's the fun part. And the instructor is the code itself. It's not the Ferris wheel. It's not the process. Process and Ferris wheel. There are the uh, those binary codes colliding together and doing the magical stuff of giving us the output. That's those process. The coding, the program is that particular instructor in between. Okay, that instructor will tell the input to go to the roller coaster or to the Ferris wheel. But if the instructor is wrong and it sends the input to a different thing, then everything breaks. Okay, if the kid who wants to go to the roller coaster end up in the Ferris wheel, he will cause commotion. Like, I wanted to have more fun, but yeah, it can happen though. Sometime it will like fell short. Maybe the kid is understandable and he takes happiness in just the Ferris wheel. But yeah, morally, if not morally, but the instructor is the one, the code is the one that is responsible for all of this. Okay, if the code mess up, if the instructor give wrong instruction to the process or the input, it the code or the system or the program breaks. Okay, we can think of it like that. Now let's go a little bit more technical. Right now, think of it, think of the program that we just did before. We were trying to add a few numbers and we were multiplying it, but right now let's just think of it like we want to add, or maybe think of it like we have these three numbers, 2, 3 and 5. Okay, and we need an output of 18. How can we do this? I'm just trying to make a simple program basically. We have these number, we have these inputs, and we need to make 18, right? We can multiply 2 by 5. That will give us 10. We can multiply 2 by 3, which will give us 6. And we can multiply 2 by 2, which will give us 4. And that will... no, not really. No, no. Okay. So if we have this as A, this as B, this as C, this can be D, and this can be E. And then what we can do is we can add these to get the output. Okay, pretty simple stuff. But in code, it may look something like this. We get the input A equals to 2, B equals to 3, and C equals to 5. Then we multiply A multiply B, which will give us 6. Let's also put this value back into B. Okay. Then we multiply A into C, which will give us 10. And let's put it back to C as well. And now we're going to add all of these. Okay. Print the output. So this is a pretty simple code. Okay. We have some inputs, a process where we multiply them together and then we add them together and then print. Okay. Now let's just think. Wait a minute, give me 1 second. There is a streaming issue going on. Okay, it's sold on its own, I guess. Anyways, let's go. So we have few inputs and we are doing processes on it, and then we are basically outputting, which is print. Right. Now let's think that the code mess up somewhere. Instead of saying over here we need to add multiply, we just say plus. Right? This is a syntax error. This is the user's error to not be able to, like the developer's error that he put it addition instead of multiplication where it shouldn't be, right? So what will happen? The output change and we get a different output every single time. Okay. Code really didn't break on itself, but we send input in a different process. We send a kid who wanted to go to the roller coaster to the Ferris wheel. Now it's causing commotion and we are getting a different result. We are not getting happiness, we are getting stress. All right. So that's what we are doing here. Okay. We are basically changing the environment just by changing one particular point of process. Okay. So that's the code. That's how everything is going to be behaving. You need to keep in mind that you need to give proper instruction to get a proper output. Now, this will be a proper output if the A into B would be A plus B. Like A plus B, what will give us? 5, right? Then 5 plus 10 plus 2, it will be 17, right? Yeah. So instead of the output, if it should not be 18, but it should be 17, then this program is correct. All of this depends on the output. What kind of output do you want? Do you want player to move from this position to that position, or do you want move, or do you want player to teleport that to that position, right? How much speed do you want the player to have while moving there? Or do the player die after that, or do it respawn back to the front position? All of these things matter. What kind of output do you want? You need to set instruction depending on it. Okay, because if you don't, the code breaks, you get a different output, and everything is basically stressful. All right, now let's go over a little bit more. Like, you might think that this is pretty difficult. Like, what if the code is thousands line more, right? What if this output we want is not just that simple? Maybe you want a bigger input, right? Or you want to make a bigger uh, code. And I would just tell you this: do not try to lengthen the code because it looks good. or do not try to compact it too much because again it looks good, or maybe you want it this way. Don't try to do that. Go with the easiest way and then try to improve it. Okay, one by one. With this, okay, again simplifying it. If you want the output 18 and we do have 2, 3, and 5, right? 2, 3, and 5. The simplest way is not to go with actually all of the things that I did. The simplest way is to basically multiply 2 by 9. It will give us 18 as well. Like, it's really that simple. So go with the easiest and the simplest way that you can make a program. If you cannot really understand how you can get that particular output, that's when you go and seek help. Okay? You search on Google, you think like how exactly can you go there, you get that particular output, and then you try to make your code. Again, the easiest way first, and then you improve it when it's working. Okay, because if you make the whole code as compact as possible, soon enough you will not be able to understand like what it's really going there. Okay, even happened to my, like, I made a really compact and fast blueprint in Unreal Engine, and then I forgot it for like months, and now I go back to it and now I don't understand like what even I made it there. I have to recreate the whole blueprint again to understand what am I even doing there. So that's it. Coding should be firstly simple, should work, okay, and give proper output. Output. These things should be the first stage. Okay, so the second stage could follow, and you can make it compact, more faster, and give maybe a proper output. Again, it should output. Okay, if you make it compact or you make it fast, but it is not giving you the proper output, it's not the code again. So make sure it does give that. And third will be the what we call it, um, perfect. Not that nothing is perfect. Okay, we cannot name it perfect. Um, Proper. Okay, everything should not be compact as well. Okay, sometimes you may make it compact, but you increase the difficulty and the readability of the code that no other person and maybe the future you cannot understand the code. So that's not a proper code. Make it understandable for everyone, other developers, and yourself, your future self. Okay, so make it proper and make it faster and make it give the output. Okay, so this should be the stages of your coding. You should firstly make it a simple code, then you can compact it, and then you can make it proper. Okay, so those are the ways coding should be done. And let me see if there's anything left, and we can talk about that as well. So many things to talk about. All right. I think most of the things I have covered here are like the one that I need. Okay. Where? Oh, we do have scale here. That's nice. We don't want it. Delete. Okay, now that we know how coding works and how everything is working, let me give you an exercise before we move on. Okay, and before I close this slide. So there's going to be a simple exercise. I'm going to make a code, and you have to tell me to get a proper input. Which code? How can I change the code? Oh, yeah, there is one thing left. The order. The order. So the biggest thing in the coding language that I have left is the order of execution. I think this is the execution. Execution. I hope the spelling is correct, but let's forget about that. So, order of execution. Now, what I mean by that is just like before, we have three inputs and we want the output. Now, as we remember, we need to do what? Multiply these two, which will give us 10, multiply these two, which will give us 6, and add these three, okay, these three together. Now, order of execution matters because if you add these three things together before multiplying them, then you will get a different output. Okay, let me show you. So let's think of it. Think of the code like this. We have the input A is equals to 2, B equals to 3, and C equals to 5. We firstly add A plus B in B, then we add A plus C in, no, not add, we multiply them. Okay, we multiply them into C, and then we add the answer of all of this to A. So A plus B plus C equals to A. Correct? And then we print A. Now, why the order of execution matter? Let's firstly go with the print. Okay, what if we take the print value, right? What if we take this and we put it right over here before we even did the first multiplication, before we did anything? Right now, the output will give us 2. If we put it here, it will still give us 2 because we are printing A, and it will only change when we are past this particular position. Now see what will change if I pick this one and move it somewhere else. Okay, so right now the print is still below. I left this. Okay, but the ABC and this whole equation comes over here. Okay, and so what will be the answer? Let me show you. So firstly, the B will be multiplication of A and B, which will give us 6. So B will be 6, and A will still be 2, and C will still be 5. So the output of A, whatever this output will be inputted inside A, which will be 7, 4, 3, 13. Okay, so right now the output of the same function, okay, we are doing same functions, but we change the order and we are getting different output. First we get 2, now we get 13, and to get a proper input, this needs to be first, second, third, fourth, and then fifth. If we change this input, it will break. Now there are some orders that you can skip, like these two. They are completely independent of themselves. But if you put them before even we give the input, then we are basically inputting nothing into nothing. So that also breaks, right? So these things should be clear. Okay, and then we can move forward. Okay, off to the exercise. So the exercise is going to be, I'm going to give you a simple basic program. We have inputs of A equals to 2, then B equals to 5, and then C equals to 15. Okay, we have 2, A equals to uh, B plus C, then we have 3, A equals to A into uh, B, and then we are printing for print A, correct? So now what we are basically doing is we are changing the value of A every single time, right? And then we are printing it. Order really matters. We want to get two outputs here. We want to get 100 and we want to get, what would be the other one? Uh, 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 hmm. Yeah, we want to get 100 and we want to get 20. So these are the two options. Now you can do this exercise if you're watching the relive. You can you're watching the replay of the live, then you can comment down. Or if you're currently watching, why not commenting? Anyways, send it to the chat. What do you think should need to change, or if it even need to change to get these output? Okay, first A and second B. What needs to change in A to get 100 and what's need to change in B to get 20? I will wait for 5 minutes. My 5 minutes now. I will wait for 20 seconds. If you're watching it, answer it. Or you don't have to, I don't know. Okay, 5 seconds are over, I don't know. Um, Alright, but the replayers, you have to answer this, okay? If you don't, it, I don't know, do whatever you want to do then. Anyways, this is the exercise, okay? You have to get the 100 and 20. This is the output, okay? This is the order one. Now, you can also get 200 here. No, 500, yeah. The next one is going to be 500. You need to get this number, but you need to change the actual code itself, okay? So that will be something like change code. Okay, so the first one will be change order and second one will be change code. Oh, wait a minute. Also, hello, Johan. I completely missed the chat that there. And yeah, hello. I completely missed it. Sorry about that. So I don't know what you mean by reply there. Hmm. Basically, this is the simple task. We have this particular code here. which we need to solve. Okay, and this print is the output. Okay, we need to print an output which should be inside A. Okay, and we need to get these three outputs here. We can change order in which like these options are being run, and we can change the code itself to get this particular option, this result. And that's the exercise before I leave, basically. And if you want to know, you can go back, watch the whole live, or I can explain to you again if you want to. But most of the live is done. So, hello, hello. Okay, audio is back. So, did you get the answer? All right. Anyone who's watching and trying to solve this, uh, you can pause it right here. If you are still trying to solve it, I will give you the answer, and then we will know, like basically. Okay, I will like, tell you about this. Just give me one more second. Okay, so now to the answer of this exercise. All right. So firstly, we have the 100 option. Okay, so for the A, there should not be any change. Right, and maybe this may have caused you the problems like, do we really need to change here because the answer is still the same? So yeah, in the first one, you don't have to change anything. The answer, the print of the A will give us 100. Okay, in the second one, if we change these two together, okay, if we do the third step before the second step, we will get 20. And let me show you how. So firstly, we put in all of the information, like all of the inputs in the first one. Then we have on the second, the addition. Okay, over here, what is happening actually is that we are giving A the value of B and C, which is 5 plus C, which is 15. Okay, so basically, when this is done, value of A becomes 20. Okay, and after that, on the third, we multiply 20 by B, which is 5, so it becomes 100, and that's how we get the output 100. But but in itself, the if we put the value, if we switch them, right, that means that over here, the value of A, which it should be 100, or maybe something else, we are basically doing this uh, step afterwards, right? This step is the last process. That means we basically overwrite anything that was inside A by 20, because B and C, we never touched them in this code, and they don't really matter that much. Okay, and that's how we get the output to be 20. Just change the order of these two, and that's how the change order exercise is done. Now let's go with the change code exercise. How we can change the whole code to get 500 as the output. Okay, right now if we go with the same code that we have right now, we can see that we are getting the output 100, and which is pretty close. 100 means we just have to multiply it by one of the top bars and we get the output. Okay, and you can do it just like that. We're going to erase the print, and then we're going to just add one more multiplication, A multiply B. Okay, or you can do it this way. You can also keep the print here, but you multiply B twice. Okay, and that's how you can get the result 500. You change the code, you didn't change the order of it, you didn't change all of the processes of it, you just changed the code. You didn't even change the input. Okay, so that's how this exercise should be done, and I hope you got it correctly. I hope. And yeah, I think left like, yeah, people like me. Anyways, so that was the live for today. In the next live, we will go over some more details, some more depth about it, and hopefully you will understand those as well. For the assignments, though, I will also give you the assignment of this. Hopefully, you will get that as well. You have to solve this on your own. So, assignment is the same code that we have over here, right? This is this same code, but what you have to do is give the human interpretation, like what is going to be the result of each of the point, like what should be the result of this in ABC, what should be the result of this in ABC, and what should be the result of this in ABC, and how will they actually change the code and how we get the result that we want. Okay, so in here you have to do the same thing that I did before. The human and the computer, or in this case we will call AI, representation of what is really going. Okay, so over here you will write in, let's say, 2 5. Okay, so A equals to 2, B equals to 5, and C equals to 15, and then you continue to do this and give the updated value in next stages. In AI you will go like a which is a memory block. Okay, so represent them as memory block, and over here you can represent them as ABC, and this is 10, this is 101, I think, and this will be whatever it will be. Okay, so you have to represent them as this, and then you can update. You have to put like the updated version of these. Okay, and that's the assignment of your today. And I will see you in the next live or video. Till then, bye bye. Ciao. See ya.